Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is David Peterson, and I'm the Director of Engineering Content for Control.com over at EE Tech, and I'll be your moderator today. Today's session is brought to you by Omron and is titled Safety in Sensing, Sensor Technology in Smart Cities. Let me tell you about today's presenter. Kerry Horan attended Georgia Institute of Technology, where he obtained his Bachelor of Science degree in Mechanical Engineering. He is currently the Business Development Manager for Omron, serving as America's technical content for Omron's diverse sensor product offerings. He has expertise in the manufacturing field, including IoT, smart city, and agriculture applications. Following the presentation, we'll have a Q&A session with Kerry, and you can submit your questions at any time during the webinar using the Q&A section that's over on the right-hand side of your screen. I would also like to mention that there will be several poll questions during this presentation, so make sure to watch out for them and answer them for Omron to understand more about your customer needs. We'll also provide our attendees with a downloadable copy of the presentation and some other resources near the end of today's session. This will be available in the Handouts tab. Thank you so much for joining us, and with that, I'll hand it off to Kerry for today's presentation.
Thank you very much, David. I appreciate the introduction, and thank you everybody for joining once again for another Omron webinar. As David said, our presentation today is on safety and sensing, sensor technology and smart city applications. Over the past few years, our engineers have been hard at work working on our technology and innovation specifically for smart city applications, and as we get into sensing technology and ways to improve it. So I'm happy to share with you some of our advancements today. A quick Omron overview for those of you who may not be aware. Omron is a Japanese-based manufacturer specializing in many different fields of operation, including industrial automation, healthcare, data solutions, social systems, solutions and service, and from where I come from, our device and module solutions. At our core, we are a components manufacturer, primarily mechanical based with our power relays, switches, and connectors, but also our sensing technology, which we've had expertise on for the past several years. As we've developed our sensing technology, we have made the move to create full solutions that are not just components for larger machines as a whole, but standalone products. And our sensing technology has been a core component of these solutions as we've developed them. Our goals overall, and especially through this technology, is to connect data and empower people through automation. In many different industries, we see a growing need for sensing technology, and not only being able to collect it, but also be able to transfer it easily to central databases and to places where data can easily be analyzed and actions can be taken to combat any issues that are being seen. But the goal with automation and communication is really as a way to help categorize that data and to react to it as trends emerge. So we come to our first poll question. What improvements are you looking for from sensing technology? We are going to be talking about three key applications that Omron is involved in here, and that's precision weather station, pedestrian safety, and overall sensor communication and integration. But if you are seeking other uses in sensing technology, we'd of course love to hear that from you as well, as we have many different fields of expertise that we can certainly help you out in. So we'll start with our discussion on precision weather sensing. As many of us have seen with ever-growing climate concerns, weather tracking has never been more important as an industry tool. Ways to spot weather data to realize trends and see if there is any indication of storms on the coast or drought in certain areas of the United States. There are many ways that weather data, collecting it and understanding the trends can really help us combat any issues that are coming from that change in weather data and adjust accordingly to make sure that everything is operating still smoothly and effectively, and above all, safely. We've seen a growing need for green energy alternatives and more sustainable manufacturing processes, those of which can also include weather sensing technology as a means to maintain energy performance, as well as ensure that the processes that are being used are done safely and effectively. And of course, all of these industries that we've seen utilizing spot weather data are requiring not only proper real-time weather data gathering, but also communication, so that even when you're in remote areas, you can have someone be able to access that weather data easily. So, in short, there does become a growing need for a device which can provide weather data as well as that seamless communication. That need for smart weather sensing data comes across several different industries that we've seen through our developments. As I mentioned, power and energy, as we've reached into sustainable energy practices, utilizing the weather data is great for energy management. Adjusting the input and output based on weather data and alerting in case of potential damage, as well as, for example, in solar energy, gathering proper weather data to make sure that those solar panels are getting the proper amount and the expected amount of energy that can be used to power the surrounding areas. In agriculture, we have, of course, seen a need for real-time weather data to capture the conditions for crops, especially as we deal with storms and or droughts in whichever respective area of the states that you are growing your crops in. There is need to manage the irrigation and harvesting equipment on weather conditions, and there is a need to monitor the conditions that the crops are going through to ensure that they're getting enough water or they are in conditions that are going to be able to produce fruitful harvests. So tracking data for crop health over time is, of course, important, and especially with these being in very remote areas, we're looking at a lot of need for long-range communication. But in the smart city, we've seen a lot of growth here for being able to track real weather data across populated areas. With these weather stations, there are ways to create a network of sensors working seamlessly with the existing infrastructure as a way to set up a web to gather the weather data across a large area. With existing power already built into the smart city infrastructure, such as with street lighting or with poles that are placed throughout the city, there are, of course, easy ways to install weather sensors to fit at the top of these areas to make sure that you're getting the proper weather data that you need. There's, of course, also an advantage in alerting the population for abnormal or dangerous conditions that are sensed and communicated quickly to a central database. So with that comes our weather sensor product. The Omron weather station is an ongoing development project merging the abilities of 7 key sensing functions. Within this singular device that you see pictured here, we have the ability to capture temperature, humidity, barometric pressure, light level, rainfall, wind speed, and wind direction. We have conducted evaluation in Japan as well as North and South America and are looking to expand our reach with the several hundred sensors that we already do have deployed. And our short-term goals include development among various communication protocols. Our current version is able to communicate well in a cellular network with LTE communication, but we are also exploring options for other forms of communication, including LoRa, to better suit applications that may be in remote areas that require communication over long distances. So we'll showcase here the greater needs for weather sensing in these industries and how the weather station can help benefit it. So we come to our next poll question. If you are looking for weather station or weather station function in your applications, what industry are you most closely working with? Is that in smart cities, agriculture, oil and gas, renewable energy, general weather data studies we have seen a lot of benefit in, or if there is something else, again, we'd love to hear about that. So I'll talk a little bit more about our weather station and how it's able to get all of this sensing data and be able to communicate it effectively. So our IoT gateway module is the core component of our weather station that allows for such easy communication. We'll be talking a little bit more about the IoT module in detail, but this IoT module is a chipset which allows for full communication and sensor connectivity. The IoT module can allow for any sort of communication protocol that you may be looking for. And as we've developed this device to connect to various different sensors, we figured that rather than as a component, we could incorporate it into a fully functioning module that would be able to work effectively across different industries and suit different needs. And so around that, using some of our existing technology and knowledge in weather sensing, we created a device called the Weather Station. That is our device module, which has our several sensing functions that are built in. And with the communication module that we have built into the base of the sensor, we are able to remotely communicate all of that collected data to that specific user. So here we have a picture of our current weather station as it looks today, which offers the sensing functions that we've talked about and several key advantages that we have in our singular housing. Number one, this right here in the picture is the full package. That makes it very easy to install. Once we have it set up and plugged in, everything will be able, all the sensing functions will be running and then automatically communicated via the IoT module. Once we get all that set up on the software side, that weather data starts coming in immediately. Because all of the sensing functionalities are in this one single package, of course, that makes it very easy to maintain. Many traditional weather stations that we've seen in the industry today include moving parts, anemometers that are collecting wind speed data, weather vanes that are looking for wind direction, tip buckets that are collecting the rainfall data. All of those functionalities are included in this weather station for optical sensing for rainfall and ultrasonic sensing for wind speed and wind direction. The ultrasonic sensors you'll see right here above the base where we have our IoT housing. And this black square right here is actually a hole that goes down into this bottom section here where the rainfall's coming in. Our optical sensors are able to track the rainfall and provide that data of rate as it comes through. And lastly, our low operating costs. As we incorporate low-rod technology, but already with our LTE technology, our software power, the power of our software within this weather station allows for a very low processing requirement that allows, so that in turn comes with a low operating cost. As we incorporate cheaper protocols of communication such as LoRa, we'll see those costs drop down even lower. But all of these different advantages coming with our product as we've developed it have been very positively received. So with our real-time environment detection, we have our experience with our former 2J-CIE environment sensor and the development of the IoT module. We've been able to put together this weather station for general weather sensing needs. As you see in this picture here, we have a screenshot of some of the data that we've been able to collect with the weather stations that we have out in the field today. But let's take a closer look at what these look like. So here we have past data from over a week. We can take the data that we've collected on some of our stations and be able to look back months in the past to see if we can gather growing trends or see how weather may have been affecting things over the past week when we might not have been around the area. With our dashboard, we're able to access weather data from the present as well as looking weeks, months into the past. As we look at the specific day, we can look specifically at the data points throughout minute by minute. We'll see here in the illuminance section, this is the one just outside our office, right when the sun reaches over that tree line at just about 11:30 is where we start getting that really bright sunlight. And one point of data that was very interesting, many of us may remember on April 8th that we had the solar eclipse. Chicago was very fortunate. I think we had about 97 or 98% coverage with the solar eclipse, but I was able to pull the data from that day specifically, and we saw some very interesting results. Of course, the illuminance we have dropped down way low as the solar eclipse comes on, so a very cool effect here. We see the temperature drop and the humidity start to rise around that same time frame, and also the barometric pressure drop right as the eclipse passed through. And then right after, we started getting a little bit of rainfall. So a very interesting day of weather that we're able to collect from the weather station that we have just outside of our Omron office. So very cool information that we're able to get from this sensor. So next we'll move on into pedestrian safety. Our pedestrian safety advancements, our pedestrian safety focus have come from advancements in car travel that have really changed the makeup of pedestrian safety. Especially in the US, we're seeing an increase of drivers along the road, which means increased chance and incidents with pedestrians. And with our increased automotive technology, we've seen smart vehicles, which have had their added controversy that they've been coming out with, wondering how they're going to be handling pedestrians who may unpredictably act or come across the road, not in necessarily crosswalks. But smart vehicles can also decrease the attention of operators as they're coming through populated areas. As these advancements have continued to grow, there becomes a need for a device which can effectively detect pedestrians and alert drivers, especially at crossing sections. So the overview of this project, our Omron engineers have worked to develop our existing HVC P2 model, and that's the picture that you see right here, our camera module here, to be optimized for pedestrian crossing applications. Usage of our body detection software that we have incorporated into this chipset, as well as our fast software processing, allow for quick communication to data crossing signals. We have also seen testing and deployment and have found success in Japan already, causing for a continued growth of this application. And we'll talk a little bit about we'll talk a little bit about all of these in the following section. So first, we'll come to our next poll question. If you're looking at pedestrian safety applications, what is the most important to you in regards for devices for pedestrian safety? Of course, safety is going to be most important, but after that, is there privacy concerns? Is there concerns with working in different environments? Maybe you're in an exceptionally cold or hot climate, or some parts of the US definitely experiencing both. Or is it quick communication and data collection? Or is there something else that you might be interested in? So let's get a little bit into the background of our experience with this particular module and our body detection technology. I gave you a quick bit of information at the start, and you may be wondering, you don't know much about this camera module. You don't know about our facial recognition technology. Well, we've had a long history of developing specifically our OCow software. OCow is the name of our facial recognition software that we have developed over a long period of time, that initially was installed in early smartphones that were looking at face detection, early point-and-click digital cameras. That technology, and you'll see similar technology in smartphones today. The way our OCow technology was being implemented into these devices were ways to detect the face in the picture and be able to focus on that specifically automatically, so you're not taking pictures of your family or friends and having blurry faces even though they're right in the center of the picture. Our OCow software was very popular on many different devices that were using this sort of technology, and from that we were able to really make a lot of key advancements into how this technology operated. Into the future, we have included this software in many different types of applications, including advertisements, including camera modules or digital cameras, security applications, and we have developed this HVC P2 camera module, which includes the entirety of the OCow software included in this chipset. We are, of course, looking to continuously expand the usage of this software and this hardware application and incorporating it into the IoT space. So a little bit of the overview of our OCow software. As I mentioned, the software was originally designed into the basic face detection application, those being in your digital cameras, your early smartphones. And as we've developed it, we've gotten into very sophisticated types of uses that it can have, including facial recognition, gender, age, and expression estimation, and expanding past the face, we've gotten into hand detection and human body detection. Now, one of the main concerns here is the ability of the sensor to not only recognize, but also make sure that it's not gathering too much information. Of course, we don't want something that is compromising on our privacy. Our algorithm has been designed to effectively recognize whether there is a face present in frame and recognize certain characteristics of that face, but also we want to ensure it performs to our highest standards of quality and privacy. So our updates to the software do increase performance, but we, of course, don't want to design anything that holds any information without anybody's knowledge or consent. So our software is able to just recognize the image that's in front of it while not necessarily transmitting the memory of the images that it has seen, but just looking at the images in real time. So as we've developed our hand detection and human body detection, we have seen increased needs in looking at these through safety applications in both industrial as well as smart city industries. So as we get into pedestrian safety applications, we have our OCal software that can detect a person that may be about to cross a pedestrian crossing and will alert vehicles to stop using an LED display. So this is especially useful when installed at crosswalks without traffic lights, and it is a better alternative to traffic light installation where we can have the specific LEDs that are only reacting to a person's presence, which can still alert drivers just as a traffic light would. The sensor using the OCal technology can send that data to a computer to alert drivers with the LED sign, and we've seen the installation of this work out well already in early installations. So that came in the spring of 2024. We had a number of systems, 10 systems that were distributed along the Saitama prefecture, among others outside of Tokyo, Japan. We had these camera modules that were placed at intersections that didn't have a stoplight that was already indicating whether somebody was present, and it would have several different people that may be crossing it in several different states of high traffic or low traffic areas. Over several months, they were able to use this system as well as surrounding CCTV cameras around the area to determine any changes to pedestrian incidents. And over that time, since the installation of the sensors, incidents at these specific points overall reduced by a factor of 50%, which would spark the development for further installations. So we've seen very successful results in how these devices have been implemented in Japan. So we'd love to continue bringing this practice over stateside and see a similar increase in safety in regions around the US. So lastly, we'll talk a little bit about IoT connection. So sensing data is critical for realizing activity trends and what reactions are needed, of course. But communication of that data is important so that analysis can be made and precautions taken to make sure that operations are running smoothly, safely, and effectively. With the proper connectivity, users can not only get that sensing data right in that moment, but also clearly communicate that trend to central databases, especially in remote areas. So as we've seen the advancements in sensing data collection, we have, of course, seen the need to actually being able to gather it. And as we've not only worked in smart cities, but also in remote areas, we are looking to create devices that are able to communicate that data effectively. So that brings us to the IoT Gateway module. Now, we have talked about this briefly with the weather station, but our goal with the IoT Gateway module is to provide a customizable solution that incorporates various different communication protocols, sensing functionality, excuse me, sensing functionality, as well as power supply. As we develop this chipset, again, we have looked into some broader ways for application and development, but we've seen the specific application in the weather station. So we have had our engineers have their practice in different sorts of ways to utilize the IoT gateway and sensing communication. Other industries that we have been able to work with on this gateway include energy management, as well as renewable energy applications, as these are also ones that are going to be collecting data at several points over the period of the day, several times per minute, and being able to get that data right away is important, especially as you're looking into power management solutions. With our IoT gateway, we are able to provide a hardware solution as well as an extensive software library that will help easily maintain that module performance. We have our software engineers and our hardware engineers hard at work in being able to create something that is easy to use and something that is flexible to be able to be adapted into whichever different application that you're looking for. So we come to one more poll question. As you're looking at different communication protocols, and that can come with weather sensing, that can come with pedestrian safety, that can come with whatever type of application you're looking for. Is there a certain communication protocol that you're focusing on, or a communication protocol that you'd really like to use much more in the future? Is that LTE, LTE Cat M1, LoRa, Bluetooth? Are you looking for a direct wire connection? Or if there is another protocol that you are most interested in, excuse me, of course, I'd love to hear more about that as well. So we'll come back a little bit to our weather station, as again, this is one of the main applications that our IoT module has been incorporated in. So within our weather station, we have all of our different sensing functions connected directly to that internal IoT module. As the weather station operates, the module is able to communicate each of those sensing data points individually so that it can be easily gathered and put onto the weather sensing dashboard that I showed you earlier. With our weather sensor module being well suited for outdoor applications, we're able to protect the conditions of the IoT module to be able to communicate that data successfully and clearly. With our wireless technology, with our LPWA wireless technology, as well as our goals to incorporate LoRa communication, that can mean the module can transmit data very easily at a very low cost. So certainly advantageous, and not only high volume applications such as smart city, but also as we get into remote areas as well. So in conclusion, I threw a lot of data at you, but Omron engineers are continuing to develop products well suited for smart city and sensing applications. Our all-in-one weather station can help collect key data for industrial function as well as user safety. Installation of the HVC camera module can drastically reduce incidents of cars entering intersections with pedestrians up to 50% or even more. And the IoT module can connect sensors through various communication networks for streamlined data sharing. Into the future, as Omron continues development on these products, engineers are always hard at work creating the next big thing. I encourage you all to sign up for our Component Insider, where you can stay up to date on all of our advancements, not only in sensing technology, but our switches, connectors, relays, and more. So one last poll question before I send you off. What further information can we provide you after this webinar? Would you like sampling? Would you like information on sampling the weather station, testing the HVC module and OCal software, discussion on the IoT module and its abilities? Or do you just want to be signed up for the newsletter and learn about whatever you can that we have to offer? If there's even more, please, of course, feel free to reach out to me. My name is Kerry Haran. Thank you once again. If you'd like to reach out to learn a little bit more, my email is kerry.haran@omron.com. and any more information that you'd like to know about, please feel free to visit our website at components.omron.com. Thank you very much. And David, I'll turn it back to you.
Thank you very much, Carrie. That was a great presentation. I was especially that part about the data that was gained during the eclipse. I got to see the full totality of the eclipse, and that would have been very interesting to compare data from around the U.S. with these weather stations. I'm definitely going to go sign up for that Component Insider too. Those are really interesting product lines you guys have.
Thank you.
So we already have some great questions. I just want to take a second to remind everybody that there's still plenty of time to submit the questions that you might have. That's over on the right-hand side of your screen in that Q&A box. So I think we should go ahead and get started on the first question that we've got today. So this first question says, can you explain a little bit more about the initial deployments, if they have continued and if it's possible for other companies to get involved, just kind of looking at a continuity of where those projects have gone from the start?
Sure. So the main initial deployments of our weather station have actually happened in Japan. We're working with a company that is deploying these stations for general spot weather data, and they've incorporated, I believe, a few hundred different sensors across the island of Japan. So we are very happy with the results that we have seen from that and the network that they have built from all of these different weather stations that are down in more tropical climates, those that are more temperate climates, colder areas. But we have seen a lot of very cool results and very good data that's coming from the deployment of these weather stations. This particular company is also looking for their expansion into South America. And so that has also been very exciting, a very different sort of climate for us to try our stations out in. And then across the U.S., we have worked with a number of different companies on testing out our station. We were just recently, we had someone hand back our weather station that had been out in the field for, at least a year. And, it obviously looked like it had been outside for quite a while, but it was very interesting seeing how well it had performed in that time.
Great. And so the next question actually is kind of a similar nature to that, but moving towards the face recognition camera setups, the HVCP2. What about the performance capabilities in harsh environments? Kind of brings to mind here, some of the conditions that might be most important are things like when it's icy outside, when there's a lot of rain. And so what measures are being taken to ensure that those can stand up to harsh environments?
So, that's great and very important. We've been looking to bring that over here, our first thought is, being from Chicago, how's it going to be through our winter? So we have currently rated the HVCP2 at about minus 20 C for temperature capability, which is, getting about 10 Fahrenheit, I believe. But as we've seen this need for the HVCP2 getting into outdoor environments, we've been doing some increasing testing in down to minus 40 and seeing how well it is capable of performing in these environments. Now, we have seen positive results in being able to at least, the cold is, of course, going to slow down any technology, but still being able to survive in those conditions. And as it comes back into warmer temperatures, we have seen still positive results on how it's been performing. But we have also been looking into different ways of protecting it. We want as little of the chipset itself exposed, of course, while still having a clear line of sight onto the intersection to make sure that we're having things operating safely. But our team is currently working on the increased testing of the camera module and how well it's performing in colder environments. So in short, we're seeing it take a little bit more than we thought it could handle and doing very well here. But also looking into the casing to protect it a little bit further so it doesn't have to necessarily experience the direct effects of a harsh winter.
So the next question asks about whether the weather sensors are capable of running on sustainable power sources. And I guess I might kind of expand that also to this vision system too.
Yes. So actually, sorry, Were you saying something else?
No, go ahead.
Okay, sorry. So actually, yes, we have had the weather stations that we've had set up, and the HVC camera modules that we've set up, and as we've deployed them out for evaluation, one particular user that we had that working with our weather station out in crop fields. We saw their setup as working on a pretty small little solar panel, about 10 by 8 inches or so. And we had the weather station running perfectly well on that. We also had in the earlier picture I showed of the pedestrian crossing signal with the HVC P2 module. All of that was running through solar energy as well. I believe that had a solar panel right on top of that. So yeah, both of these are capable of running on sustainable power sources. Certainly important with the weather station that it is a pretty hefty device, but certainly in what we've seen, very capable of running on power sources that don't need that direct connection. I know that can be difficult in remote areas.
Yeah, absolutely. And especially considering that the power sources themselves have to be able to withstand those harsh temperatures and conditions that we were talking about earlier.
Oh, yeah.
So the next question says, what other products is Omron working on within the space of smart cities?
So within smart cities, I will sort of pivot back into sort of energy management. I mean, that becomes a very big component as we get into these smart cities. We've seen a lot of advancements in solar energy, being able to, advance cities up to more sustainable energy practices, energy management solutions, EV charging capabilities. We have a number of different power relays that we have been developing that work within that smart city space. So, and all across all of those different industries. So certainly a product that we have a whole lot of experience in. But as we are incorporating them into these energy and technology areas, that is of course something to definitely consider. Another one is with our non-contact battery charging. We have a lot of developments in that. We had done some developments with bike share applications in using the contactless battery charging. So another one that we are in development on for the smart city space and very excited about.
Great. So this next question, you kind of alluded to the answer earlier, but maybe we could just kind of reiterate it a little bit because there's curiosity about that. But with the HVC P2, it's capturing image data, and you mentioned a lot about privacy for data. Obviously, we want accessibility of data, but we also want privacy for people. So what measures are being taken to ensure that privacy when it's gathering images?
Sure. So what the HVC P2 is, it is, capturing the image, but it's not necessarily gathering the image data. The data that it's really capturing is the coordinates of, where they're seeing the face, where they're seeing the body. So it is in a way, it has to process the image to take a look at the shape and understand whether or not there is someone present in there. But with the camera module itself, there is not really a space for any sort of processing memory to capture all of that image data and be able to even hold on to that for that extended period of time. So, for example, if I were to walk in front of the HVC module and it recognized my face and I step out of the frame, if I come back, unless I have physically taught it to recognize who I am, I would walk back and it would just sense just another shape of a face that is in the frame. So there is not really an ability for the camera module to be able to capture, save, and recognize unless directly instructed.
And the next question stays on the subject of the cameras, but it says for non-Omron cameras, if I have my own camera, is it possible to run the OCal software on it?
Yes, absolutely. Our OCal software is designed for the OCal software is designed for the ability to work on any sort of camera. So if our HVC P2 module was developed for those who might not have their own camera module, so just as an all-in-one solution that has all of the OCal software embedded into the chipset, being able to use all the functionality at once. But the OCal software is actually something that can be very customizable to your specific solution. So if you have a camera module and you're just looking for something that is maybe detecting the face, or just detecting maybe where their eyes are looking in case you're trying to monitor where they might be paying attention, the OCal software can be packaged to be very specific and have very specific functionality within your specific application and within your camera module.
Okay, and the next question is, it says, does the weather station product come pre-certified? And I guess, again, kind of expand that question to talk about the HVC as well, pre-certifications for these products.
So yeah, our products, of course, come pre-certified, and all that information we can certainly provide as you're looking for more information on those products.
Okay, and we're kind of coming to the end of the questions here. Just want to again take a moment. We have time for the audience if you have any other questions to submit those in the Q&A box over on the side of the screen. And so our final question here says, where can I find data sheets for parts, for the specs for various parts?
Yeah, so all the data sheets and specifications for our parts can be certainly found on our website. Our weather station not being officially released just yet. If you would like more info on it, I encourage you to please reach out to me or reach out to your local Omron rep. They'd certainly be able to get in contact and get you all of the right information you need on the specifications, the data sheets, and any other info you need on any parts that you might be interested in.
Do you know if there's a rough timeline on the release of that weather module?
We're looking into next year for it. And we do have, of course, as I said, several that were deployed. So we're very close to having that final design, but we're looking into next year for that weather station. But any samples or any devices that you're looking to test with, we have the ability to have some produced for you and get your project going underway.
That's great. I will definitely, I think I'll be keeping an eye out for that kind of product release. Very exciting.
Yeah, it's great. We're very excited about it as well.
Carrie, well, once again, thank you for the presentation, all that great insights, and for the discussion during the Q&A. That was a really great discussion that we had today. Thank you.
Thank you.
And I also want to, of course, thank our audience for their participation today. And in just a moment, you will be redirected to Omron's website, where you can view more information about the weather sensors so that you can get started on your own meteorology projects. And you'll also be able to view this session on demand using the same link that you used to view this webinar. So if you'd like to view it later or share it with somebody who was unable to make it today, then you can share that link with them so that they can see it. We thank you for your time, and we look forward to seeing you at another live session again sometime soon.